everybody. I know that some of you guys are having trouble with homework number 3, so I'm going to go ahead and work out 6 different problems, and hopefully that helps you. So, looking at this, we have a simplifying rationals problem, which is the first part from that homework assignment. And here all we have to do is we have to figure out what does the top and the bottom have in common. Now, sometimes it's not very obvious, and sometimes it is, right? So in this case, we have 3x at the top, and then we have x squared at the bottom minus 3x. Now, one thing to notice here is that you have an x at the top and x is at the bottom, right? So I'm going to just write it like this. So it looks like I'm factoring out an x, right? And right now it might not seem like obvious why I'm doing that, but at the bottom we have x to the second power minus 3x. So we can factor out an x like this, right? So x times something gives me x to the second power, so that's x. And then x times something gives me 3x, or in this case, minus 3x. So minus 3. If you were to use the distributive property, you can see that that is correct, right? So in this case, for example, we have x minus 3. Let's use the distributive property, right? X times x is x to the second power, and then x minus 3 is minus 3x. So it's the same exact thing that we have actually in the other part, right? So that is the equivalent to this, right? And that's kind of what we're doing here. We're just factoring things out. Now, if you notice, the top and the bottom have an x in common. So cross that out, right? This cancels out that one, right? Because we have x divided by x, which is just 1. And we are just left with 3 divided by x minus 3. And that's your final answer here. We have nothing else to factor out. Okay, so now let's go ahead and move on to the next example. This one looks a little bit more complicated. And we kind of have to treat this as two separate problems in the beginning, and then try to see if we can cancel anything out in the end, right? So now the top and the bottom look very different, but that's what we had to find out. Do they have something in common? So I'm going to go ahead and write out the first one and ignore the second one for right now. So I'm going to write it in blue here. So I have x squared minus 2x minus 35, right? Let me see. Okay, and now in this case, since it is a trinomial, and the coefficient of the first term is 1, right? So this one out here, it's a 1. So it's kind of like saying 35 times 1. And now let's go ahead and write out the factors that give us 35. So the factor that I want to use is, and the first one that comes to mind, is 7 times 5, right? Because 7 times 5 is 35. So then go ahead and ask yourself, okay, so if I add or subtract 7 and 5, or 5 and 7, can I somehow get that middle term here, which is negative 2x? So yes, right? Because we have negative 7 plus 5 is negative 2. So in this case, that's what we're doing here. We're going to go ahead and split this into the following, right? So we have x squared, and then we have negative 7 x, and then we have plus 5x. Because once again, negative 7x plus 5x is negative 2x. So this is just kind of like a clever way of breaking down numbers, and you're completely allowed to do that. It's like saying 9 is equivalent to 10 minus 1, right? Or 8 is equivalent to 10 minus 2, and so on, right? So you're allowed to break numbers down, and sometimes that makes sense. Sometimes it helps you kind of reduce things and simplify things a little bit further. And then we have that negative or minus 35 at the end. And now we kind of treat this as two separate problems. That's the way that I approach this. So I'm just going to look at the problem on the left and then the problem on the right. So the problem on the left here would be this one, and then the one on the right would be, let me use red, I guess, right here. So the left one, we're going to go ahead and kind of do the same thing that we were doing up here, where it's a little bit simpler. So the left one that I have underlined in gray, we have x squared minus 7x. And in this case, what they have in common is an x, right? So I'm going to factor out an x. And then I have x times what gives me x to the second power? Well, x times x. X times what gives me 7x? Well, minus 7x, or 7 minus 7, sorry. And once again, if you use the distributive property, you should get x squared minus 7x. So now let's go ahead and look at the two terms on the right-hand side. So we have 5x minus 35. So I know that 5 goes into 35, right? So that would be the greatest common factor. So I'm going to go ahead and factor out a 5, right? And then I have 5 times what gives me 5x? Well, 5 times x. 5 times what gives me 35? 7, but since there's a minus sign, it's negative 7, right? And would you look at that? The middle terms here happen to be the same. And if that actually happens, then that means that this can be factored out. So it's kind of like going back here, right? What do these terms have in common? Well, they have an x in common, right? What do these have in common? They have a 5. But now if you look at the whole thing, once it's been factored out the way that you see it here, what do all of these, what does this whole thing have in common? Well, x minus 7. So we're going to use the same kind of principles and factor out an x minus 7. And if this doesn't make sense, like imagine this is, forget about x, right? Let's look at over here, right? So say that we have x times, um, let's put a letter here, y, I guess. X times y, and then we have 5 times y. Oh, what does this have in common? A y, right? So we can factor out a y, and we would be left with x plus 5. In this case, what I'm saying is that this is a number, right? We don't know what x is, but it's something, right? And we can treat it the same. So all we're doing is the same exact thing that we were doing before, which is we're just going to factor out that thing that I wrote in black, x minus 7. So I have x minus 7, okay? And then I have x plus 5. That's what's left, right? And in this case, if you use the example that I have on the left, it's kind of like saying y x plus 5, right? Hopefully that makes a little bit of sense here. All right, so now we're going to go ahead and do the same thing, but now we're going to do the bottom term. So at the top right now we have, so this is equivalent to, the top would be x minus 7 times x plus 5. Alrighty, so now let's go ahead, I'm going to go ahead and erase this though. And now we have the following one, which is x squared minus 15x, right? So I'm going to write it here. I guess in blue, well, red, I guess. So I have x squared minus 2x minus 30. Oh, that's the top one actually. So it's going to be x squared minus 15x plus 56, right? So in this case, once again, we're going to do the same thing. Let's go ahead and write out all of the values that when I multiply gives me 56 because the coefficient here is 1. So we have 56, right? Is equal to, the first one that comes to mind would be like 7 times 8. So 7 times 8 is equal to 56. So now, can I somehow get with a 7 and an 8, can I somehow get a 15, a negative 15 to be exact? The answer is yes, right? So we can do this long method that we just did, and this long method really only shines when the coefficients isn't 1, but there's a little bit of a shortcut method, right? The shortcut being that if you're able to recognize right away that you have two terms that are in common, and the last term is negative, so I know that there has to be a minus sign somewhere, right? The reason being that the way that we get this last number is that we use the distributive property, and you multiply the last number, the second number from each term, right? So then from each factor. So, negative 7 times 5 gives me negative 35. So that's where this negative comes from. So the shortcut method would just be, okay, I know one of them is minus. Well, the only one that makes sense would be, or negative, right, would be if 7 is negative, because we have to add 5, and that makes sense to get negative 2. So we're going to use the shortcut method here and say, I know that it's 7 and 8. So then I'm going to go ahead and write out x, and then in this case I have a negative 7, right? And then if you think about it, negative 7 minus 8 gives me what? Negative 15, which is this one right here. And let's see if it works out or not. So negative 7 and negative 8. So that makes sense, right? Because if you were to multiply negative 7 times negative 8, well, that gives me a positive 56, which is the plus sign at the end, right? So that would be the shortcut method. So I'm going to go ahead and write my terms out here. So I have x minus 7 and x minus 8. My factors here. Oh, it's going to be a minus, right? Okay, so now you can kind of see that these actually do have something in common, and that is the x minus 7 right here. So that means x minus 7 divided by x minus 7. I don't know what x is, but they're the same thing, right? So it's kind of like saying 100 divided by 100. It's going to be 1. So these cancel out. And what are you left with is x plus 5 divided by x minus 8. That means that this whole thing at the top is the same thing as saying x plus 5 divided by x minus 8. And if you were to graph them, they would actually be right on top of each other because that would be the same exact thing, right? Alright, so now moving on to multiplying and dividing rationals here. So the first thing we do is we can either factor things out or we can multiply across. Now, I would recommend trying to factor out first, because if you do that at the end, it might become a little bit more complicated, because you might have things that have to the third power or fourth power or something that's at a higher degree. So I'm going to go ahead and treat these kind of like separately. So I know that the top is x squared minus 64. So let me write it down here. And this is a square value, both of these. So this can be rewritten as x squared minus 8 squared, right? So, because 8 times 8 gives me 64, we can use the difference of squared formula, which means that we can rewrite this whole thing as x plus 8 and x minus 8. So that one's easy, right? X plus 8, x minus 8. All right, so now let's look at the next one here. I guess the bottom term, right? Yeah, I don't want to go across yet. So let's do the bottom term here for the left-hand side. So I have x to the second power, x squared minus x minus 72. And now I have to figure out the factors of that give me 72. So the one that comes to mind here would be 8 times 9. So 8 times 9, right? And then that gives me 72. And let's use the shortcut method here that we used previously. So I know the last term here is minus. So I know that one of these terms has to be minus, and that's what we need to figure out. So we have a 1 here. So go ahead and think about, okay, 8 and 9. Can I somehow get a negative 1 actually? Because it's a minus 1, right? By adding or subtracting 8 and 9, the answer is yes, right? Because I know that negative 9 plus 8 gives me negative 1. So then that means that we're going to have a term that has x minus 9, and the other term is x plus 8. X minus 9, x plus 8. All right, so let's write that down. X minus 9, x plus 8. All right, so maybe you're seeing a little bit of what we're going to be canceling out already, but let's not get ahead of ourselves. Let's look at the right-hand side here, and let's look at the 4x minus 36. I'm going to split this off here. I'm going to write it in green, I guess. 4x minus 36. So here, what do these have in common? Well, I know that 4 times 9 gives me 36, so let's try that out. 4 times what gives me x? Well, 4 times x. 4 times what gives me 36? That's going to be 9, but since there's a minus sign, we have to keep that minus sign there. All right, and I think that's it. We can't factor it out any further, so we're just going to write it down like that. Times 4x minus 9. Let's put the division sign down here, the fraction. And then let's work out the last one, which is x squared minus 8x. So I guess I'll write this one out in, let me see, purple. All right, so then we have x squared minus 8x. Here, what do we have in common is a x, right, in both terms. So let's factor out the x. We have x times what gives me x to the second power, x times x. X times what gives me 8x? Well, 8. And in this case, I think this was a plus, right? Did I write it minus? I don't know why I wrote it minus here. The example I had was plus, but I guess it doesn't really matter in that case. But let's keep it as plus, right? So sorry about that. I miswrote it out here, which is fine. Yeah, so let's leave that as plus. All right, so then in this case we have x times x plus x times 8, right? Or x times x plus 8. And let's go ahead and write that out. Okay, so then what we're going to do is we know that we have an x plus 8 and an x minus 8, right? So in this case, let's go ahead and cancel these out maybe. What do they have in common? Let's see here. I'm going to cross out this x plus 8 with this x plus 8. And this x minus 9 with this x minus 9. And I think that might be it. So we're left with 4 at the top times x minus 8. And then at the bottom we have x, x plus 8. That's it. That's all we can factor out in this case, right? So we can just leave it like that. All right, so next we have problem 4, and then we have x squared minus 3x. Right, so let's go ahead and move a little bit quicker here. So we're going to use the same idea where we can just use the shortcut method. So x squared minus 3x minus 54, and we can use the shortcut method because it turns out that if we do this, we can actually make it go a lot quicker here. But let me go ahead and rewrite this though, because I've noticed that since you are using the division sign in the middle, It's probably a little bit better if you write it out like this. Remember that if you ever have the division sign and you're dividing like two things like you're seeing here, um, technically it's kind of like saying this whole thing goes under this value, right? This whole term. So that gets really messy. So the best thing to kind of alleviate that would be to use the reciprocal, right? So whatever I have at the top, I'm going to go ahead and switch it to the bottom. And whatever I have at the bottom, I'm going to go ahead and switch it to the top. So this is times x to the third power minus 9x divided by x squared minus 81. All right, so then now let's go ahead and work this out. So here, what is the factors of 54? Well, you can write out all of the factors, but I know that the first one that comes to mind that might work would be 6 times 9, right? 6 times 9 gives me 54. And I know that one of these terms has to be negative, and that's what we had to figure out. Well, in this case, I know that negative 9 plus 6 actually gives me negative 3, which is this middle term right there. So in other words, we can rewrite this as x minus 9 and x, let me see that, plus 6. It's a lot easier, right, to work it out like that. Okay, so then that's what we have here. And let's go ahead and write out what we have. So I have x plus x minus 9, right? X plus 6. Okay. So now we're going to work out the bottom from the left-hand side. So we have x to the third power, right? So x to the third power plus 4x squared. And these just have a x to the second power in common. So let's factor out x squared. So we have x squared times what gives me x to the third power? X times x squared times x. And x squared times what gives me 4x squared? That would be plus 4. Use the distributive property if you want to go ahead and prove it to yourself that that actually works. So we have x squared right at the bottom here. X squared, and then we have x plus 4. Alright, so now let's look at the left, right? I'm going to write it in green here. And we rewrote the top to be x to the third power minus 9x squared. So here we're going to do kind of like the same idea that we did on this terms right here. So we can go ahead and factor out x to the second power. X to the second power times x gives me x to the third power, and then x to the second power times 9, and we're going to keep the negative sign there, gives me minus 9x squared. So that one was pretty easy. So I have times x squared here, x minus 9, divided by the last one, which is x squared minus 81. And I guess I'll write it in gray here. Now, one thing to keep in mind is whenever you see a square value, you should immediately think, hey, can I use the difference of squares formula here? And in this case, this can be rewritten as x to the second power minus 9 squared, right? And guess what? We can use the difference of squares formula, which gives us x plus 9, x minus 9. And if you don't believe it to be so, go ahead and use the distributive property, and you'll notice that the middle terms will cancel out, and you'll end up with that. Alright, so we have x plus 9 and x minus 9. So I have x plus 9 and x minus 9. Alright, so next, finally actually, we can go ahead and cross out things that I know or have in common, right? So I have an x minus 9 over here, and I have an x minus 9 here. cross those out. And then I have x plus 6. I think I wrote that as minus here, right? Yeah, so then we have an x plus 6. Cancel that out. And then we have, actually there's nothing to cancel out there. We're going to keep that one. Keep that x minus 9. But we can cancel out this x squared. And I believe that's it, right? X plus 4 somewhere. Nope, that's it. So this one actually looks kind of messy, but we can actually reduce it as x plus 6. And then we have x minus 9. And then at the bottom I have x plus 4 and x plus 9. So that's the most that we can reduce this one. Alright, so next let's look at adding rational expressions. So here we just have 2, and this is maybe a little bit easier. So here we have the following, right? So we have negative 2x at the top, and let's go ahead and add these up, right? So what we have to do is we try to find a common factor here, and sometimes it's a little bit tricky, but let's go ahead and in this case actually it's not tricky at all because we have the same denominator, which works out for the best here. So this we can actually rewrite it as negative 2x plus x, and then 2x plus 3 at the bottom. Okay, so that at the top we have negative 2x plus x is just negative 1x, or just negative x. And at the bottom we have 2x plus 3. That's it. Now we can rewrite it like this as well. This would be equivalent, right? Because it's kind of like saying negative 1 times this whole thing. It's going to be the same exact thing. So that one was easy. Let's go ahead and move on to the other one, where perhaps the terms are not the same, the denominator. In this case, we have a 3 and a 2, and think about this as just like regular multiplying fractions, right? There's two ways of doing this, and I'll show you both ways. The first one would be, can we figure out a factor of 3 and 2? And the first way I would want to do it would be, let me rewrite it here. I guess method 1. And there are similarities here, which is 7. Let's look at the left-hand side and the right-hand side. So I know that 3 and 2 don't really have anything in common. Like, in other words, 2 doesn't go into 3 and without giving you a fraction, right? So now let's go ahead and multiply this side by 2, 2 divided by 2, and then the left side I'm going to multiply by the term at the bottom, right? So 3 over 3. The reason we do this is because 3 divided by 3 is 1, 2 divided by 2 is 1. So you're kind of multiplying by 1, and this is just a clever way of doing things so that we don't actually change what we have, but we kind of do, right? So it kind of looks different, but it's really the same thing. All right, so then we have 2 times 7. We're going to multiply across, right? Like this. So we have 2 times 7, which is 14x, 2 times 3, which is 6, minus 3 times 3 is 9, so we have 9x, and then 2 times 3 is 6. So if you notice, we made the bottom term the same. So we have 14 minus 9. Well, let's rewrite it like this so it looks a little neater. So whenever you write it like this, it means that you're dividing both the 14x and the negative 9x or minus 9x by 6. Okay, so then we have 14x minus 9x. That's going to give us 5x and the 6 at the bottom. And that's it. So you're done. Now the other method is a little bit more Looks a little difficult, but in reality, it's kind of like the same thing we were doing. This method's always going to work, but sometimes it gives you things that are more complicated. So in this case, it would work perfectly. But in cases where you have like factors that are not whole numbers, for example, if you have an algebraic expression at the bottom, it still works, but you would just have to do more algebra, in my opinion. So choose your method wisely. And the method basically looks like this. If you have a over b, and you're adding or subtracting, right? So I'll put plus minus some other term here, c and d, then you can cross multiply, and this would be AD plus minus BC divided by BD. So in other words, we cross multiply, and then at the bottom we just multiply across, like this. This is what I mean. You're multiplying these two terms, and then you're multiplying these two terms, and then finally these two. Alright, so let's do the same exact problem, but we're just going to go ahead and rewrite it and see if it actually works out a little bit easier in this case. Okay, so according to this method, I have 7x times 2 minus 3x times 3 divided by 3 times 2. So 7 times 2, that's 14x, minus 3 times 3, that's 9x. In this case, 3 times 2, 6. Then I have 14 minus 9, that is going to be 5x at the top, divided by 6. So guess what? We got the same exact answer. Using two different methods, although in this case they kind of look the same, right? So choose the method that you want, and it should work either way. But I hope that helps.